Hello and welcome to the OutSystems webinar about troubleshooting mobile applications performance. My name is Daniel Reis and I'm a front-end expert at OutSystems, and I'll be your host for this webinar. This webinar, it will be about troubleshooting and performance. It's not about solving performance issues, it's about how to detect those performance issues. The agenda for today. First, we need to know the field where we are working on. We need to know what is happening under the hood. Then, you'll know the available tools that we could use to work in that field. With those tools, we'll try to find some typical issues in mobile applications. In the end, we'll wrap all these and we'll put all these together in practice. So I'm going to show you some metrics. It will be very fast. And half of the population in the world has at least one phone. So this is very, very important. 83% of Facebook users accessed by smartphone. So only half of them will access in the laptop or in your desktop. So nowadays, we'll start to access more, even more to the web page and applications by our smartphone. 39% of the share of the page web views are made requested by my mobile phones. Only 66% nowadays it will be requested by laptops and desktops. So we'll have here a 21% of increase in smartphone requests and a decrease by 9% in the desktop since the last year. So this is very, very important numbers because they are very important because nowadays we start using each more our smartphones, and we need to improve our applications and to be more faster and to get a better performance. So what people expect about mobile applications? Well, 47%, almost half of them, expect a page load less than 2 seconds, and 77% expect a website load faster in a mobile application. And I'm one of those guys. So if a web page is not loading in less than 3 seconds, probably I'm going to change my application and I'm going to look for another one which will have the same characteristics that I'm looking for. So the loyalty for application or website, it will be managed by the loading of the page and how fast is that application. So knowing how it works. Well, in this chapter we'll see what is happening under the hoods when you request a file and we are trying to present the web page. We'll see what is happening, the life cycle of that request. Then we'll see what is happening in the browser. So since the time we get a response until the time we actually see what is happening in that page, we see the page itself, and then we'll see some characteristics that we need to realize for the mobile applications. So how the web works? We'll start for the page lifecycle, and it will start in DNS lookup. So the DNS lookup, it's when the DNS translates an internet domain into an IP address. So we can know where the web page is located in the web. After that, we'll have the TCP control connection. So the TCP is when you establish a connection with the server. We have the three-way handshake process, and this process is based on the 3 steps synchronization. The first one will synchronize. The second one is to synchronize an acknowledgement by the receiver, and then you'll send back again the acknowledgement. So if this three-way process succeeds, we have established a connection with the server. After that, we'll have the HTTP request and response. Well, the protocol request, it's when the web server will start to looking for what the client needs. And the response, they will send a numeric response code. That numeric response, it will be the server response. And after that, imagine if you have the 200 response, we'll know that is okay. So it will render it will apply the source code sending by the server, and will render finally render in the browser, and it's the render page as we see it. So it's the final process of the request. So we have some situations which will happen in this process. The first one is the bandwidth, and the bandwidth, it's the channel that determines the rate of data transfer between point A and the point B. So the bigger the bandwidth, more data can be transferred in a quicker speed. So the page, it will be loaded faster. The bandwidth nowadays, we have the 4th generation wireless network, and you can say, oh yeah, my application will not have any trouble at all because we have 4G. Well, that's not the case, because some of the times we are using the 3G connection and the 2G connection. So we'll need to have this in consideration, because even with 4G, you are not use the 4G when you think you are. So you need to get this in consideration. Latency. Well, latency, it's a very hard and very long process, because latency is the time to ping. So a package reaches the destination from one point to another point. And the big problem with the latency is that every time we start to request some resource, the latency will be there. So we need to get this in count. The TCP slow starts. Well, the TCP slow start is a mechanism to protect the server. So after we establish the 3-way handshake connection with the server, and we start to send some package, for instance, the variable here is 4. We'll start to send a 4 package to the server. Then the server will respond, and then we'll send another 4. So it will be 8, and then 16, and then 32, as you can see here. So why you can send all the 64 at once? It will be much faster. Well, the server don't know if we have a good bandwidth, if we have a good network, so it is more like a protection for the server. So they will start with the low numbers, and they will increase the number. So when it reaches the top of the connection, it will fall back to the last number, and then it starts all over again with the same variable. So the goal here is to stay straight in the top and not pass that line here. So we want to get the most powerful and available connection here, but we don't want to blow our connection and blow our application. So the parallel request, it's also a protection made by the server. So imagine in the browsers, like in Chrome, you have 6 parallel connections per host, and this is to reduce the internet congestion. So we can protect the web server. Well, here you can ask again, why we don't have 20 parallel connections? Why we don't have more? Well, if you imagine when someone is trying to use something like torrents, well, in the torrents, if you're trying to download 20 resources at a time, they will be a much slower download. It will be a much slower download. So most of the cases, people tries to download once at a time. So it will be okay. After that, I will start another one. So here the process it's similar. We'll start with 6 resources at once, and then when the first one finish, it will pass to the next one in the line. So we'll have the page loaded in a faster way, and we'll start seeing things happen in the browser instead of get all 20 at the same time. That it will be much in the end of the process. So we know how the web works. You know, other things happen before we get the response by the server, and we understand that some of those things we don't have the control that we desire. However, in the browser, this could be changed, and we have that control, and we need to and could make those changes in the browser to have a smoother application, and we'll see right now. So, how the browser works. We have the critical rendering path, that is a very dark process, and then we have the repaint, the reflow, and the composite. So, the critical render path. Well, you have the document object model, which is the parsing of the HTML received by the server. It will define the events, the methods, the properties of each one of those elements. Parallel with this, we have also the CSS object model. It's not, no one talks about it, but it's very important because here we have it's very similar with the DOM, but we have the style sheet and the rules applied from those elements. And then both combined will have the render tree. And the render tree, it's when you join an element like a div, and then you will apply those properties like, okay, the rules, if that div have background red, for instance. So you have a DOM and you have the CSS object model, and both combined will have the render tree. So here, as you can see, most of the people confuse the two of them. So here in the DOM, you can see that we have the head, the meta links, and here in the render tree, we don't have those elements. And if you hide a div or an image in your page, that image which will be in the DOM, but will not appear in the render tree. So it is quite important to know the difference between the two. After that, we'll have the layout. The layout is the exact position of each element of the render tree. Then these positions, they are just coordinates, and we'll see the rendering. After that, we'll see rendering in the page. So it is more like a data model of coordinates to render to the screen after this process. And that process, it will be the paint. So the paint is when actually we'll display the page into the browser as we see it. So as you can see, to get to this point, we'll pass through a lot of things, and some of them, they are quite expensive, as you're gonna see it in a bit. So reflow. Okay, so we start our page, and we start loading, and we complete the download page. So the page is loaded, and okay, no problem about my application right now. Well, not really, because sometimes even after the page it's loaded, we start doing things in our JavaScript, like changing position of elements, the width, and that kind of stuff. So that's that thing. It will be applied, and again in the render tree. So we start compute this all again, and this we'll call the reflow, when you change a dimension of or a position of an element. So for instance, imagine you change a width of an element, so that element it will need to be painted in the future. But the children of that element, it will be affected by them. So they will need to be painted again, also. And the parents of those elements also need to be painted. So in the end, you will paint everything until the top of the document. So you'll paint all your render tree. And this is quite expensive, a very expensive process here. And we need to avoid that. This is some things that could be easily triggering this process about the reflow. And take a look of the offset width and scroll. We are using a lot of these, and sometimes we don't know or we don't understand what is happening here. So we have also the repaint. And the repaint is when you made a change of a property of element, but it's just a style property. So imagine I have a div with background red, and now I'm going to change it to background blue or black. So in that case, I will paint that element. But so it's only a style property. It will not change the width and that kind of things about the element. So it will only paint this element. It will not paint the other elements. So the big difference between the reflow and the repaint is the repaint which only paint the element that we changed, and the reflow will paint all the elements around this one. So it will be much more expensive. So we have the composite, and the composite, it's out of the critical render path. And why is that? Because the composite is where we manage the graphic layers, so and use the GPU instead of CPU. The critical rendering process use the CPU. So the composite will use just the GPU, and this is quite important. So okay, I want to start using the composite. Well, you can promote the element to a layer. You can use the GPU, of course, and avoid painting, and you have a faster and smoother render in your page, because it will only trigger the composite layer. So how can we do that? Well, we can use the wheel change property, the method for optimize animations. It will inform in advance the browser which things which will probably change in that element. So as you can see here, you can use like this. But if you want, you can also manipulate the z-axis with translate 3D and translate z, and you'll have the same feature. But the big difference here is that wheel change property is the most recommended to use. So after promoting an element to a layer, we'll just stick to composite, and it will use and it will be out of the critical rendering path. So this is the goal we are aiming for, and it will change a lot the performance of our applications. I have here a demo. In the left side, we can see standard animation by JavaScript, and in the right side, as you can see, is we are using the layer, so the WebKit transform, and it's much smoother. So now we already know what is happening under the hood. We already know the tools that are available, what is happening in the browser. Now we are going to see some characteristics about the mobile applications. Well, you probably heard about iOS pseudo browsers. Well, the reason here is that for experience purposes, in the Apple, in iOS, we only have one browser, the Safari. So if you install a Chrome there, and you are not using the Chrome, just the UI of the Chrome, but in the back you are using the Safari render engine. So a Chrome in iOS, it will be different from a Chrome in Android or in your desktop. In Android, we will have the Chromium since the version 4.4. And this is the open source project, and the performance, it will be much faster than previous the 4.4. And in the version 5, in the Marshmallow, you can actually update in the Google Play separately from the Android platform, so you don't need to wait for the operating system update. Here we have some tests about this. The performance increased a lot in overall results, and if you can see, in HTML and in JavaScript, it's past the 300%. So there is also a thing that is happening in the iOS. It is the delay of the click. This also happens in the past in the Android. Nowadays only happens in iOS. But there is a reason for this. It's the browser needs to know and to identify if it's a single click or a double tap, or if you are zooming something. So it is more like a protection for the browser to know what is happening here. You can use fast click, for instance, to correct this situation. Okay, recap. So web pages are slower than mobile and device in mobile device applications than in desktop, most of the times, of course. We understand that many things happen before we see the page in the browser, and it's a dark path. While on network, most of the time we use 2G or 3G, and please avoid to use a repaint and reflow. Instead, stick just to composite. It will have a big performance impact in our application for the best. So we already know what is happening in all this cycle. We know the field. Now we need to know what are the available tools to apply so we can improve our application. We'll see we'll have the Chrome DevTools. We'll make a deep dive there, and then we'll also talk about the remote debugging inspectors, and we'll connect our device to our laptop so we can debug remotely. So we are gonna go now to the browser. I'm gonna present here some of the tabs that I want to talk about. And we have here a network and the timeline. Those two, it will be the ones I'm going to talk right now. So the network, we'll have here the cascade, and we'll see a list of the resources that the browser needs to download so you can see the page. Here we have the process for the download, since the queuing until the first byte and then the download of the resource. We'll have here also columns that we can manage and choose from right click of the browser. We can see, okay, I want to see the cache control, the content encoding, the domain, and they will be displayed here. So it will be very, very good for seeing what is happening and then to detect some changes that we need. Here you'll have the strips, so what is happening when the page is loading by in the timeline, and in the top we can choose what we are going to see down here in the list. So if I just want to see the image, I'll click here. If I just want to see, for instance, fonts, I'll click here. This checkbox here, preserve log, is quite important also because it's when you click, if you have checked here, you can preserve this log when you are changing pages. Down here and up here, we can change a preset of the network, so we can simulate the network if it will be in 2G or 3G, as you can see. And we also have this rendering that you can check to enable and see the paint flashing. It will be in green, and you can see the frames per second here. So we need to be at the 60, because 60 it's when the rendering it's much smoother, and in 30 it will be actually take the critical point. So we need to be just in the 60s and not in the 30 frames per second. After that, we'll have the timeline, and the timeline here we can record some process. Imagine that you are seeing your menu here, and you want to check what is happening there. You can record the process here, and will appear that process in this timeline. And you can choose whatever you want, and these little red dots, is not dots, but these little red things here, they will it's when we reach the 30 frames per second. So we are looking for these ones to try to improve our application and the performance in our application. So imagine, I know that it will be probably a script because it is always JavaScript who is reach this top, because if you are using compositing, it will not. So I could go into, imagine this one, and I could see what is happening there, and click and go to that function, and after that I could work a little bit more in that function. So to get a more a better performance in my application. So we also have here a flame chart view, and this is quite important because we can see the functions when they are applied and why, and you can see the paints and the layouts, constructions and changes. And you can see one very important thing here is when you see those little red triangles here, you can click and you know it will be, and you will see here a forced reflow. So a forced reflow, it's important because the browser nowadays they are quite clever, and they when you make your changes in your code, in your scripting, and to paint something, the browser, it will queue all those changes, so they will try to change it at once. However, sometimes if you force a reflow, like seeing if the scroll, like using the scroll, or measure a width of an element, etc., it will trigger that, and they will flush all the queues. So you need to go and search for those red things here, and then you can click into into the element and go to the JavaScript, and you'll need to search a little bit here and try to improve that until you start again all over, and this forced reflow will disappear. Okay, so you're gonna back to our presentation. So just a little recap about this. So we have in the network, we could choose our columns. We could choose the ones we think we will need to view, and then to get a more instant result of what we are looking for. We have the network, the process for each one of the resources, the queuing, the request send, the waiting, and the download. And we also have these ones that I didn't talk about, but it's the difference between the green ones, the paint, and with the green stroke around is the reference page. The first one, it will be a data structure, of the elements, and the next one it will be when to render into the browser. So it will be actually the paint process. We will have the reflow, so you need to go there to see what you can do better in that function, that particular point. And we also have the layers that you can see, and I'm gonna as you can see here, we can see the layers, and we can see if, okay, this one, it will appear because it will have will change composition properties, so it will have its own layer, and here it's very good here to manage the layers. But don't forget, don't try to use to put everything in a layer, and don't try to do that, because if you have too much composition layers, it will decrease your performance as well. So we'll talk about now some remote debug inspectors. We have the winery inspector, which is based in Node.js, and it will tag you will have a tag to put in your file, so you can remote inside the network. SilkUI uses this. You have a side property that you can trigger there. Also Adobe Edge Inspect, which uses also winery. We can also use it, and they are very good tools to remote debug. However, we are trying to stick to the Chrome DevTools and to connect our device and to see it there in the Chrome DevTools. So to install your Android in your Windows to get to remote debug, you have to download all of these things, like the Android SDK and USB driver for Windows, and you will need to start every single time the ADB devices. So you have here a print screen, and then you need to go to this page, the inspect devices, and it will appear here the page that we want to debug. We'll click in the inspect, and we'll see something like this. So on the page, it will be here. Okay, so what about for a Mac? Well, you just need to plug in the cable. You don't need to install things, nothing like that. You just need to plug in, and you'll see it in the same view. You'll see it your device. So recap. Well, we understand the network requests and how we can see it in the Chrome DevTools. We detect some reflows and repaints, so we can use those tools in our advantage, and we know how to debug and how to connect our device to the desktop, so we can debug remotely. Now we have the tools. Now we need to go looking for the typical issues in mobile applications. So first of all, I'm going to talk these issues, because in most of the cases, the problems that we saw in applications, in most of the cases are because these type of issues that I'm going to talk. So and those issues you can manage and see them in the browser, and we don't need to go just straight to the mobile and start debugging in mobile, which it will be much slower. So in the first case, which I saw in one client, and the client wants to use a background image with a gradient. So, but the the background image almost have 2 megabytes. It's very big image. So it's not, of course, it's not a good optimization because it takes too long to download the image. So we compressed in a lot of ways, and we use the optimizilla.com. You can use that. It's a very good website to compress image, and we get a very good image size. However, it takes too long again. It takes almost 3 seconds to load that image. So that is not the thing that we want. We start then we split the image just with 1 pixel. We then repeat it in the x-axis, an old school process, but it's still too low to load. The loading is not very good, so it's not the things that we are looking for. So why not to just make your gradient in CSS? So it will have an instant render in the browser, and you will see it in a better way. Of course, if it really needs a gradient. But however, the real important thing here is try not to use image to apply the style you want to your layout. Just use image if you really need to like an article or something, but not to the layout. Use CSS instead, and that is applicable also to icons. If you can, please use fonts like Font Awesome or make your own font. So this is another typical issue. Imagine that you have image in desktop that you don't want to load in phone. Of course, there is a very good approach, but sometimes, and in most of the cases, people just hide the image. So they use display none or visibility hidden, and they think that okay, we will not see it, so we will not pay for that image. Well, that is not the case, because the image it is not in the render tree, but is in the DOM. So will not be displayed in the window, but it will be downloadable. So we'll pay for the size of that image, and this is not a good practice at all. So you can use a class or media query to know and display the image just in the device you want, or you can use, because this is not a good thing, because you need to know the dimensions of the image, but you can use something like the SilkUI display on device pattern, which will be you put the image just in the device you want to show, and the other ones the image will be not rendered. So you'll have here a link to the webinar SilkUI from Basics to Advanced. Take a look, and you'll learn more about the SilkUI framework. So this is definitely what we are looking for. Well, about fonts, it's a hard process to have fonts. The important thing here is nowadays there is no single universal format for web fonts. So some web browsers will use WOF by default, and other ones will use TTF and so on. So it's the biggest problem here is because we don't have a universal format. So we need to use all of them here. So we need to fall back to one to another, etc. But I'm going to tell a case, because I saw in a client once they have 2 CSS, one for the desktop and another one for mobile devices. And the only reason they have 2, they told me it is because they wanna load a font in the desktop, and they don't want to load a font in the mobile devices. Well, you can have the same CSS, because if an element calls the web font, it will be downloaded, as you can see here in the desktop. But this CSS, it will be downloaded from the mobile devices also, but no element in the render tree here will call this rule. So no problem at all, the font wouldn't be downloaded here. So uncompressed resources. As you remember, we saw the cascade in the network, and we could choose there with a right click a tab that we want to see in the column. So I choose to see the content encoding, and then I can see there if the file is zipped or not zipped. And this is quite important, because nowadays gzip, most of the cases we are using gzip in the pages, but sometimes this is not happening. So we can see the difference here. This document, the size and the content, it will be almost the same. And here we download just 12 KB, but the real size of the content, it will be 65. So the gzip, it's a compression that it's made in the server, and when you download it, uncompress that file. And this is very important to use, because it will increase our performance. So external resources. We can also see in the tab, in the columns, we can choose the column of the domain, and we can also see where the file is hosted. And this is very important, because sometimes we are depending of external resources. And imagine that if one day the file is not there, you will have an error in your website. And if it will be something like a JavaScript, it could be very, very, very bad. So excessive resources. Well, try not to lose too much resources in your mobile applications, because they are meant not to be. Imagine you are in the street and you don't want to download all of these and pay all of those files that you are downloading. And in this example with the CNN, we have 86 images downloading here. I probably don't need 86 images, because I'm not going to the end of the page. So in this case, you could use something like lazy loading or some similar approaches. And cached resources. Well, also in the cascade, we can see if you can choose the column to see if the resource is cached with or not. So this one is not cached, and those you can see they are cached. But some you can see the time here if they have like 1 month and 1 year, and this is quite important to know. So parser blocking JavaScript. Well, this is a very, very hard hurdle, because when you trying to download the JavaScript, you start downloading one file, and then all stops, because after that the browser don't know what is the process to take, so they will wait to download the file and read the file, and then it will pass to another file. It could be another JavaScript file. You can use a sync, so you can do every file that you want at the same time. However, you need to take in consideration, because if the file loads first than the other one, and if the first file needs something like a function or a variable that it will be in the second file, it will blow our application. So recap: optimize your image. Do not use image for any sort of layout styling. Please do not do that. Use fonts instead of sprites. Sprites, they are quite difficult to manage. Improve the usage of fonts, and try to not use too much fonts in your web application. And compress your resources, compress and use cache for them, and attention to excessive and external resources. And also take a look to parser blocking JavaScript. So now we learned what is happening under the hood. We learned the dev tools that are available to us. We learned how to search from the typical issues. Now we are going to put it into practice. So my application is slow. Where to start? Well, by default, troubleshoot first in the desktop browser console, because most of the cases we can reach them by the desktop, and we don't need to go to the mobile first, because it will be a much slower process to despite these problems. Then in the network, in the DevTools, search for the typical issues, and in the timeline, look deeper into painting and scripting and try to find some forced reflow bottlenecks. And after that, if it fails, okay, then go to mobile and start remote and start debugging remotely. Okay, so now I'm gonna see. Okay, now we are going to see again I already connected my device here, my phone, and you can see a web page here. And as you can see, it will be very, very slow to process here. So this is one reason that we recommend first trying to debug in your desktop and then go here. So here I already choose to have the column of the cache control, the content encoding, so the domain, so I can easily make an audit here and see, okay, I have a lot of files that are not cached. I have too much files that are not zipped. So this is, of course, it will have a big impact in my application. Also, I have too much domains here, as you can see. So this web page depends a lot from different domains. It's not good. And as you can see, the document object model loaded after 3 seconds, but the whole page loaded after 42 seconds. It takes too long to load. So we have here the timeline, and you see that is happening a lot of stuff here, and we need to try to avoid that. So this page is not definitely a good page. So here in the timeline, we have also some of the things that are happening here, like functions, and we catch one of reflow here, and we can go there to the JavaScript, and then we can look a little deeper and try to get a better performance here in this function. Okay. Now we are going troubleshooting in OutSystems now. So what is OutSystems now? Well, OutSystems is an application built in OutSystems, and you can use there your hybrid applications and iOS, Android, and Windows applications. So we can test our application in our mobile device and see what is happening there. I'm gonna change here to my tablet, and you're gonna see my application in OutSystems now. So, okay, as you can see, now you'll have an option here about the web view, and in this web view is my inspect page that I'm gonna open here, and you can see this page is inside OutSystems now. So you'll have here also the network and the timeline. I'm gonna make here, just press to load the page. And now we are debugging inside the OutSystems now. So as you can see, we have a lot of files here zipped. Okay, very good. But okay, something is missing here. And as you can see, it's the external domain. So try not to use files again outside your domain, because it could be failed in the future. We have a lot of files here failing. We have 5 images that are failing. So it will be this is a thing that we need to avoid. We also have the timeline here, and this is all the same as we see previously in the desktop, and as you see it in the phone in the last example. So once again, in the timeline, we can go here and look for forces reflows and trying to realize what is happening here and trying to understand and try to improve. Okay, this is a fire width happening here. So I need to see if I really need this and when we need it. So, but this is not the aim of this webinar. Okay, so some concerns that we need to have about OutSystems now. It's older one about a problem about the slow applications in Safari. It's already reported to Apple, and I have a link here to the forum, so you need to go there if you want. And no, okay. And we have also something you need to have consideration in iOS is the slow page transitions, because only after when you transition a page, the image from the previously only it will load after not the document ready, but the window load page. So recap. Well, we review the basis. We saw what is happening under the hood, and we saw how the page, when you make a request for a page, what is happening before the page reach the browser. Then we saw what the browser needs, and the critical path of the browser to bring the page in our browser. And after that, we saw the dev tools and how can we detect some things which we can apply to the typical issues in mobile. After that, we put in practice, and we saw just 2 little applications, one in our browser and another one in the OutSystems now, so we can see and start working and start using those tools in those applications. So don't forget, look for the signals, know how to change, and how to debug remotely. So the final recap. So know how it works. The web pages are slower in mobile devices than desktop. Many things happen before we see the page in our browser. While on network, most of the time we are using 2G or 3G, and avoid use repaint and reflow. Instead, stick to composite. We already look into the dev tools and the available tools, and we understanding the network requests and detect reflow and repaint, and how to debug remotely. We saw the typical issues in mobile, so the no image optimization, improve your usage of fonts and compressed resources, external resources, excessive resources, and cached resources. Also, we saw parser blocking JavaScript. in the end we put into practice, and okay, we start looking into the signals and know where and how to change, and we debug remotely in OutSystems now in a web browser. Okay, thank you. Now I have just little links here for your interest, if you want to take a deeper look, and some links to the previous webinars and the